Hello ladies and gentlemen, so today we're going to look at graphing square roots. What you're going to want to have on you, graph paper with your notebook, a pen or a pencil, and then a calculator for the day. So a little bit of review, some general shapes that we've talked about already. Y equals x squared, if you remember that was a parabola. Y equals the absolute value of x, that was a V, and then y equals mx plus b, that was a straight line. X cubed, if you remember, that kind of looks something like that. And then x to the fourth, usually it looks something like that. Alright, so now today we get to add a brand new function. Yay! Today is the square root functions. So a square root function is going to look something like that. So it's always going to have just one area. It's going to start at 0, 0, and it's going to shoot off into the corner. So the general table of a parent square root is going to be 0, 1, 8. No, excuse me. Not 8. 1, 4, and 9. So now, what you're going to want to do is plug those in. Let's get our y's. So 0, square root of 0. We know that's 0. Square root of 1. That's 1. Square root of 4. Well, that's just 2. And the square root of 9. Well, that's just 3. So my table is always going to be 0, 1, 4, 9, 0, 1, 2, 3. Your domain, your x values. Now, if you remember, last time we looked at domain, we had to see and think, whoa, if we have a radical or a square root, you had to take that x and set it greater than or equal to 0. So your domain is x is greater than or equal to 0. Because notice how I don't have any x's over here. I have only over there. Your range, though, if you look at your range, whoops, your range must be greater than or equal to 0 as well. So some shifting and stuff that we've covered. If you remember, we had just normal x squared. That was just what it normally looked like. So something like that for our square root. Now, if you did a number on the outside, especially as -8, what did it do for you? It made you go up or down, right? So we have a vertical shift of, oh, that should be shift. That should be an F, not a shirt. Up and down, outside the main function. So when it's outside here, that made you go up or down. Just like it's the same thing with square roots. A negative on the outside there. We had one that would go inside right here, and that made you go left or right. Remember, it was always opposite of what you thought. So this one would have gone left, 6. So same thing, if you have something on the inside, it's going to go left or right. If you have an A on the outside or a number on the outside, like this 1/2 here, that's going to make you either stretch or compress, depending on how you're moving around. And then the negative on the outside, that makes you flip the function or reflect it across the x-axis. So the majority of what you're going to want to have down is this part right there. None of this part really is important. This part is very important down here. So let's make this table first. And I'm going to kind of see here, kind of think of how my change is going to do this. So I have a -3 on the inside. So remember, we're going to think opposite. So instead of thinking left 3, we should be thinking right 3. And then up 4. So I'm going to go right 3, up 4. That tells me where the start of my square root function is going to actually be. So right 3, up 4. That's going to be my very first point right there. So 3, 4. Now, to generate the rest of these numbers, That, I think, is the hardest part. If you remember, our original table looks something like this, right? So I'm going to ask myself, how did 0 become 3? What did I add or subtract from 0 to get 3? Well, we added 3, right? Added 3 here. So we're going to do that with all the same numbers. I'm going to add 3. So 1 plus 3, that's going to give me my 4 there. 4 plus 3, that's going to give me 7. And 9 plus 3, well, that's going to give me 12, which I can't really graph on this, but that's okay. Let's plug in a 4 here. So I'm going to have the square root of 4 minus 3 plus 4. 4 minus 3 is 1. Square root of 1 plus 4. Square root of 1, that's just 1. So 1 plus 4, 5 is my answer there. Plug in my 7. So 7 minus 3 plus 4. 7 minus 3, that's just 4. So square root of 4 minus 4. Square root of 4 is 2. 2 minus 4, negative 2. Just showing my extra work here. On the next few I won't. I'll just talk through it. Square root of 12 minus 3 plus 4. 12 minus 3, we know that's 9. Square root of 9, well, that's just 3. And 3 plus 4, well, that's just 7. So now we can actually graph this. We have 3, 4. We already have that point. 4, 5, right there. And 7, negative 2. Oh, hold on. Something happened here. Oh, I should have added 4 there. Silly. So we should got 6. So I have 7, 6. Right there. And I can't graph the next one. So we get to put a line just like that. Don't put an arrow on this side, only an arrow this way. Domain now. Let's take whatever under the square root, set it equal to 0. Or set it equal to greater than or equal to 0. Add 3. I get x is greater than or equal to 3. Your range, though, what's the highest or lowest y value you were able to use? 4. So y must be greater than or equal to 4. Let's look at this one. Negative x to the 1/2. X to the 1/2. Let's change that. Let's make that the square root of x, right? So then we can see it as a square root. Nothing got moved except this negative is going to cause us a little issues. So I just get to use my normal parent table, 0, 1, 4, and 9. Notice how these are the perfect squares, 0, 1 squared, 2 squared, 3 squared. That's why I use those. Square root of 0, that should be 0. Square root of 1, 1. Negative, that's a negative 1. Negative square root of 4, that's negative 2. Negative square root of 9, well, that's just negative 3. So let's go ahead and graph this. We have 0, 0, 1, negative 1, 4, negative 2, oops, and 9, negative 3. Shoot off into the corner just like so fashioned. So your domain, my domain didn't change, so it's just x is greater than or equal to 0. But my range did. I'm not going above 0 this time. I'm going below 0. So that tells me that I need to be less than or equal to 0. Let's try this one. So they say the negative 1/2 square root of x. So I have an x and I have a y. Nothing changed underneath the x. I didn't add or subtract to it. So I just get to use my normal parent table, 0, 1, 4, and 9. The 0 gives me square root of 0, 0, still just 0. Plug in my 1, so I have negative 1/2 square root of 1. Square root of 1 is just 1. 1 times a negative 1/2, well, that's just negative 1/2. Negative 1/2, square root of 4. Square root of 4, 2. 2 times negative 1/2, that's just negative 1. If you did that on the calculator, you'd get that. Negative 1/2, square root of 9. Square root of 9 is 3. 3 times negative 1/2, well, that's just negative 3/2. This one kind of has a little bit of a dirtier numbers here, but that's okay. It'll give us a graph nonetheless. Excuse me. Got a little carried away there. 0, 0 goes right there. 1, negative 1/2, about right there. 4, negative 1 goes here. And 9, negative 3.5 is about right there. So my graph's going to look something like that. Your domain now, nothing under the radical, so we don't have to worry about that. That's just x greater than or equal to 0. Your range, we didn't move up or down, but we did flip, so that's going to flip our sign. Now, could you, would you, if I would ask you to write an equation of a square root graph that's shifted up 5 and upside down, we need to think of a way to write that. So shifted up 5, well, that means you're going to add 5 at the back, right? So I'm going to have the square root of f of x, let's name it f of x. And I'm going to add 5 at the back because it's up 5. How would we flip it upside down? A negative on the outside. And we're not going to have anything else in the inside, so it's just going to be negative square root of x plus 5. That is the end of the video for tonight. See you later.